Yeah, yes, madam. Yes, sure. May I know the slide? Yes, yes. I'll do that. I'll just change the slide. I wanted to check whether I can see I can view the slides. Yes, and I wanted to see whether here. Yes, there's a pointer. Do you see there's a pointer? Yes, you see that? Yes, there's a pointer. Do you see? I'm using a pointer on HPLC. See the red pointer. You're not able to see my screen? Yes. Do you see the pointer? Yes, right? Okay. So I'm using slides and I think everything is visible. Do you see them clearly? Okay. So I'll be also talking about few words about my company and the training program we offer in chromatography and mass spectrometry. That will be in the end. Yeah. So shall I stop sharing? Shall I stop sharing? Can you hear me? Am I hearing clearly?
그게 아니구나. 거기서 아니 아기도 너무 좋을 때. उनके यहाँ पे खाली 9 लोग हैं, तो उसमें कैसे लिखेगा कि खाली 9 लोग ज्वाइन है। उनको आने देना चाहिए क्योंकि यहाँ पे 9 लोग है ना, वहाँ अच्छे नहीं दिखता है ना। इनके पहले इसमें भी कॉमेंट मारी गई है कि आपका भी खाली 5 ही लोगों ने लेके आए, किया है।
Greetings to everyone. On behalf of Srimati Devkiba Mohan Singh Ji Chauhan College of Commerce and Science, I'm your host, Dr. Ami Oza. I welcome you all for today's webinar entitled Chromatography, Multifaceted Analytical Technique. I extend my welcome greetings and virtual floral bouquet to our chairman, Shri Fateh Singh Ji M. Chauhan, our secretary, Shri Devdas R. Shah, our treasurer, Shri Vishwesh Dave, members of our trust, our resource person, Dr. Deepak R. Thakur, director of ACR NS Technologies Private Limited, our principal, Professor Dr. Ambadas Jadhav, and our most valuable delegates who have joined us virtually from different parts of my country, different states, Maharashtra, Gujarat, Tamil Nadu, Karnataka, Kerala, Orissa, Bihar, Uttar Pradesh, Delhi, Rajasthan, Jammu and Kashmir, Meghalaya, Andhra Pradesh, and Punjab. Also, we have a few delegates who have joined us from Mexico, Riyadh, Pakistan, Ethiopia, Egypt, and Saudi Arabia. This truly shows the power of chemistry and chromatography to bring people from diverse areas onto one platform. I would now request our principal, sir, Professor Dr. Ambadas Jadhav, sir, to deliver the inaugural address. Over to you, principal, sir. Yes, sir, you're audible. You are audible, sir. Yes, sir, yes, yes.
We are having all conventional basic sciences because even the government of India is also giving more emphasis on the basic sciences. We require scientists, researchers in basic sciences because most of the students the management has started law college also in 2017. This year, the first batch is going to come out. In that one, we are having 5 years course after 12th standard in law, and then 3 years course after graduation. So, friends, those who want to enroll in our college, you are welcome to come and witness our college, our teaching, our library, our infrastructure,
Ma'am.
and you will come
How you
to
doing?
know how
Yeah.
the college is. So once again, I invite you to take admission. I invite your wards, your children to take admission in your college in various courses. So with these words, I conclude and over to our management team. Thank you very much.
Thank you, sir. Thank you. Thank you, sir. Thank you for your words of encouragement also. Moving ahead, chromatography is a chain which connects individuals at various levels of their own journey in life. Starting from separation of green pigments or colors in marker pens at schools and high schools, to separation of colored ions at graduation, to checking the completion of reactions, detecting byproducts, etc. at post-graduation level, going deeper into its various facets during research and postdoc studies, and finally at the professional stages of our career. Chromatography is always present with us. Chromatography is actually a journey of our own life. Various stages of our life are the stationary phases, and time is the mobile phase that leads us to pinnacle in our profession. It is exactly 120 years ago that Michael Sweat, botanist, who introduced the experimental technique. Today, this technique provides solutions to challenges pertaining to detection and estimation of pharmaceuticals, adulterants and additives in food, stage of the food and dairy products, that is, extent of spoilage of food and dairy products, identification of active ingredients in herbal products, detection and estimation of nucleic acids, proteins, amino acids, to forensic sciences, to biotechnology, to perfumes, to flavors. It goes on and on and on. Just to show that what is the reach out of chromatography. I would now like to introduce our today's resource person. He is Dr. Deepak A. Thakur, Director, ACR&S Technologies Private Limited. Sir has done his master's in physical chemistry from University of Mumbai. Sir has done his PhD in protein characterization from Department of Chemistry and Chemical Biology, University of Barnet or Barnet Institute, Northeastern University, Boston, USA. Sir has an illustrious career of 25 years of academic and industrial experience. Sir is associated in services of areas like consulting and responsible for development of mass spectrometry based methods for testing and characterization of pharmaceuticals and biopharmaceutical products, specifically monoclonal antibodies. Sir is associated consulting for setting up a small molecule and protein characterization lab, consulting for development of bioanalytical methods for PK and TK studies, representative for protein metrics, partner lab for mass spectrometry in the lab, scientific consultant with Zele Biotechnologies Private Limited. Sir has been a general manager in biotechnology analytical R&D from January 2013 to June 2018 at Wokhard Research Center, Wokhard Limited. Sir has led and managed overall scientific and technical operations efforts of a group of analytical scientists in the primary responsibility as to develop and execute analytical testing strategies such as setting up quality target product profile and critical quality attributes. Sir has led a center of excellence with deep expertise in high-end protein characterization, impurity characterization, and cell-based functional characterization. Sir has supervised and guided development and optimization of analytical methods for testing and characterization of biopharmaceutical products, which include, for few, biochemical and immunochemical assays for determination and demonstration of clearance of process-related impurities, mass spectrometer-based methods for identification of related proteins or impurities, analytical ultracentrifugation-based methods for study of higher order structures and higher molecular weight proteins. Sir has also developed analytical method validation and method transfer system. Sir is associated with preparation of documents for regulatory submissions for different analytical team rights, analytical testing procedures, etc. Development of LCMS, MS-based bioanalytical methods for pharmacokinetics and toxicokinetic studies of biosimilar and novel formulations, management of multiple projects, support for quality and manufacturing units, training, budgeting, and planning for current and future projects. Sir has acted as a scientist or analytical lead, technical development, Novartis vaccines, and diagnostic Cambridge MA from 8 2011 to 12 2012. Sir has had and worked as a research assistant or PhD student and has published various different types of different publications. Sir has been associated with Store City USA. Sir has been an analytical expert with Sandoz Mumbai. Sir has been an assistant manager with Nicholas Piramal Mumbai from 1998 to 1999. Sir has been associated with USV Limited Mumbai. Sir is also awarded with Bristol and Earth's Gleason Memorial Award in Advanced Research, Barnard Institute, Northeastern University in 2008. Sir is having 5 different international publications. And in short, Sir is a person who is always motivated and always ready to help individuals come up with new solutions, find better understanding to the existing systems, and to provide solutions which are capable of giving us directions and process that help us to achieve the best results. Without taking any further time, I would now request our today's dynamic resource person, Dr. Deepak R. Thakur, to please take over. Over to you, sir.
Thank you very much, Dr. Ami, for this introduction, and thank you to Dr. Jadhav for support in arranging this particular session. There are many faculties who are very interested in betterment of the society and students, and Dr. Ami is one of them who has taken the lead in having this particular session. So I congratulate her for arranging this session. So welcome all. I know there are people from different countries today on this particular call, and I'll begin this presentation. I'll just check whether it's loaded. I hope everyone can see my slide now. So as Dr. Ami has mentioned that ACRNS Analytical Technologies, which I founded 2 years back in June 2018, we do consultancy, we provide distributorship, and we also do training program. As many of you may be aware through LinkedIn that last 2 months, we did extensive training program in chromatography, mass spectrometry, bioseparations, and we have got very good response. Students were really enthusiastic to learn these techniques, which are widely used in the industry. As you have just seen, you have heard about my experience. The, the best experience I received is during my PhD program when I got to work with international scientists who were engineers who were making mass spectrometers, columns. They were developing softwares, were responsible for developing statistical tools. So I was fortunate to work with them as a PhD student, as a person responsible for working on the applications of this tool. That's what I consider my best experience in my career. So today we will be discussing about the advances in liquid chromatography. And the outline of my presentation is I will begin with the journey to high performance liquid chromatography. High performance liquid chromatography, called as in short HPLC. What are the components which are responsible and what are their roles in overall performance of HPLC? Again, among these components, HPLC column is the heart of this instrument, which is responsible for separation of compounds. Further, different type of chromatographies we hear about is based on the nature of analytes and their interaction with the stationary phase. We'll try to focus on Vam-Dimter equation today because this is very important to understand the performance of chromatography system. Why do we need advances in chromatography system? What are the challenges in conventional HPLC columns and how the advances in column packing, that is micro pillar array column manufacturing, how this helps and provides better. We want to understand that how these features are used, whether this is a chemical industry or a pharma industry or it's a biopharma industry. And in biopharma industry, beyond that, there are so many therapies are coming up. And in these therapies, like there is a RNA delivery system or cell therapy, in all these chromatography has a role to play. Those advances, those application, one of the application I'm going to cover tomorrow. Tomorrow is a day when, same time we'll be presenting the second part of this presentation series, when we'll be covering application of micropillar array columns for biological samples. So today the goal is to understand what is chromatography and what are the factors which are responsible for performance of chromatography, what are the challenges, and how does the new advances like nano LC chromat columns and then micro pillar array columns, how do they provide better separation, better performance during the chromatography. So to start with, I'll first talk about the journey of high performance liquid chromatography. Many of you are already aware about the picture you see on the right hand side. And when you see a separating funnel here, this is so you see a separating funnel here, and this is the basic tool we see in most of the labs. But it has a big lesson to teach us. Separating funnel in which you can do extraction of different compounds. Think about basic extraction we do is simply we make a coffee or a tea from the powder we get, tea or coffee powder. It's an extraction. And when you brew this coffee, how much water you use, how much temperature you use, what volume of water you use have a role to play in extraction of different compounds, and that provides a special flavor. So people, the coffees and teas are very famous. Individual, some brands are very famous for particular flavors. And if you go to Google and search, you will come to know that it's an extraction process. It's an extraction process which is responsible for extraction of different compounds which lead to the test. So I come back to separation funnel in which you take an extract of from plants, from soil, and from there, from this extract, you want to separate specific compounds. How do you do that? You add a immiscible solvent. And why immiscible? Because you want to recover that solvent from the other solvent. Then when you add that immiscible solvent, the selection of solvent depends upon nature of compound you want to extract. And this particular, these two layers are shaked vigorously. Why do we shake them? Because we want to bring different layers of solvent A in contact with solvent B, and then between the two layers, there'll be a extraction. Now, what we see here on this side, after shaking them and letting them settle down, you see that the compounds which have higher affinity for this particular solvent have moved into that. They are solubilized into the second solvent. If you want, but you see still some compounds left out in the previous solvent. So what you need to do, you need to bring in another fresh layer of solvent. So remove this solvent and bring in another layer of solvent to interact and extract the another amount. So what we learn from here is we need multiple aliquots of this solvent to extract a compound from the original solution. And this forms the basis of chromatography, that you need a stationary phase. This is our stationary phase, and this is our mobile phase. We are changing it. Once we extract this, to extract rest of the compounds or molecules, what we do is we add another aliquot. This is manual, but when you want to automate this, that becomes chromatography. The first attempt towards this was by Russian botanist Twest. What he did was he invented column chromatography. So what he did was the phase which he packed inside this column, glass column, was calcium carbonate, which acts as an adsorbent. And on that, if you see the layer here is a mixture of pigments. What he did to separate them and to collect them was run a petroleum ether. When so here this was the immiscible solvent and which was added to the original solution. Here the stationary phase, here the stationary phase was liquid, here stationary phase is solid. On this stationary phase, we are adding a mobile phase, and as name suggests, it is mobile. That means is moving. And with moving, what happens? As we saw here, one aliquot is not sufficient to extract all the molecules. You need to add another fresh aliquot. So this mobile phase provides you fresh aliquots. And through this process of addition of fresh aliquots, you separate these different compounds. And why do these compounds separate? Because they have different affinity for stationary phase. So this is about the interaction of solute with that of stationary phase, and this interaction is dependent on different type of forces which govern the capture of these compounds on the stationary phase. Further, this is still manual process. Further, in order to automate it, Dr. Jim Waters developed HPLC instrument, which is high performance liquid chromatography in 1970s. And as chromatography word comes from chroma means color and graphy means to plot, to write. And we see the existing HPLC instrument produce a graph like this on the right hand side corner, that the detector detects these compounds and you see them not only a unique retention time, but their relative intensities. Their height in this graph indicates what is their intensity in the complex mixture. Further, we'll see what are the components of HPLC which enable the performance of chromatography, overall chromatography. The goal of chromatography is to separate as many compounds as possible. First one, which plays a big role, is a mobile phase, and mobile phase is made up of solvent reservoir. Mobile phase is made up of different solvents, so you need solvent reservoir. Solvent A is usually an aqueous buffer solution, and B is an organic phase. Then you need degasser. These solvents may have gases which are dissolved in them, and you need to degas them. Further, you need pump. Why do you need pump? Because these columns which are packed with micron size particles, passing liquid to them is not easy. And especially with the flow rates you need for faster separation, it's going to be difficult. So you need special pumps to pump that mobile phase through the column. What is the role of injector? Injector has a role to inject sample on the column. And who helps them to transport these samples from injector to column? Mobile phase. Because as mobile phase flows through the loop of injector, it carries that sample to the column. Column, as I said, is the heart of chromatography, because in the column you have a packing of particles which are immobilized with ligands. And these ligands are called as stationary phases. These ligands are called as stationary phase. So the interaction of your sample with the stationary phase, and again interaction of your sample with the mobile phase, leads to overall separation of different components present in your sample. What is required, very important, is a detector. How will you detect that the compounds are getting separated? Merely with eyes, that's not possible. That's never possible. That was only possible on column chromatography when the compounds were pigments visible. So detector has a big role to play. Detector has a small flow cell which is similar to cuvette, which we use in the spectrophotometer. So these are the components of HPLC which are responsible for overall separation and detection of different compounds. We will focus on chromatography as today we want to see what are the advancement in chromatography. So what we are going to see is what is the advancement in HPLC columns. So let's look at what is the status of existing column hardware. So when you look at the right hand part, you will see that the casing used to pack these beads, silica beads, which are immobilized with different type of functional groups, these are packed in these casings, and these are the columns. So columns can be, the casing can be of glass, can be of PEEK, and can be of stainless steel. And stainless steel is the one which is widely used. So these are the different types of columns with different dimensions. You get columns with different lengths, with different particle sizes. So right from 30 micron to 1.7 micron, you get bits, silica bits, which are immobilized with different functional groups as per the nature of analyte. Here, what we see is the scanning electron microscope images of particles. On the left-hand side is silica particle with 1.7 micron. And as you see, come on the right-hand side, they are ranging in the sizes. They up to 30 micron are available. And what is the beauty nowadays is you get spherical particles, uniform in their, the uniformity has increased, the heterogeneity is decreased. And what we see on the right hand side, if you see the difference between the two, what you see is these ones are non-porous. So these beads are having no pores, but these beads are pores. And if you see the picture below here,